please go to the tasks to complete for today. This is Unit 3, Lesson 1. Welcome to our skeletal muscular system, getting into what a lot of people really think of when they think of human anatomy and physiology. Again, you're looking for tasks for U3L1. You can find it either under assignments on the Human Anatomy and Physiology Canvas page, or look at the weekly calendar on the homepage when you scroll down and find today's date. Start off with our usual speed meetings, throw you into breakout rooms for a quick share. We'll come back and I'm going to throw the question in the chat right now. Here is the question. You have your own late night talk show. Who do you invite as your first guest? Could be a celebrity, could just be a friend, doesn't matter to me. Who would you want to talk to on a late night talk show? You guys haven't answered this question before, right? No, cool. All right, I'll give you 20 seconds to think about it. Throw you in breakout rooms to share. Okay, so newborn babies have fewer bones than adults. That is false. Most of you got that. They actually have more, and it's just because there's a lot of bones that haven't fused yet. They have a lot of cartilaginous bones in particular that haven't even really ossified to become firm. Over half of the individually unique bones in the human body can be found in the hands and the feet. Very good. And I think this was something Bryson hit upon that is true. Every human has the exact same number of ribs. Very good. That is false. You can have what are called false ribs, which don't come all the way around to the sternum. And these can cause some health problems with people, especially if they're poking other organs. Every bone in the human body is connected to another bone. This is very torn on this one, but it is actually technically false, and it's only one exception, which is called your hyoid bone, which is actually in your throat, which I know is weird to think, but if you kind of feel your throat right below your chin there's a little kind of a horseshoe-shaped bone there that is serving, again, a kind of a protective and holding role for the trachea and a lot of your throat structures. Humans are one of just a small percentage of animal species that actually have bones. That is true. Most insects, right, have exoskeletons. Even a lot of fish actually are what we call there's bony fish, and then there's a cartilaginous fish, which don't actually have, like, you'll never see a shark skeleton because they don't have bones technically. They have a cartilage skeleton. The only thing you ever see of them is their jaw and their teeth. That's it. Teeth or bones, that is false. They are actually a slightly different category. They're a lot harder because of their enamel. It's a bit of a different structure. Bone is stronger than concrete, assuming equal weights. That is true. Again, this always blew my mind because I was like, wait, but if I fall on concrete, I usually break my bones. But it's because, again, if you were to keep the weights the same, right, they're stronger by weight. Have you ever broken a bone? So let's see. Quite a few people have not. Fractured tibia, right knee, oh man. Only fingers, possibly tailbone. Yep, tailbone's really common. Sprain, never. All right, so we had a tibia and a right knee. So who is the tibia? Who fractured their tibia? Doesn't want to share? You want to stay anonymous? Oh, was that during baseball?
No, football.
Oh wow! All right. And who was the what was the other one? The knee. Keone? How'd that happen?
Cross country and growing a lot. So
oh, okay. Yes, that'll do it. So, who said fingers? Did someone say they broke a finger? I don't know. I'm like you. I have managed to avoid those injuries, and so hopefully that will always be the case. I have torn ligaments before, but no bones. So, and hopefully it will not ever happen. So glad you're all safe as well. Cool. All right, let's see what next task. I want to use some slides. I'm wondering, we've got a little bit of time before we delve into the activities. So I think I will go with this a little bit. All right, so I'm going to throw this out to you. The skeletal system often kind of gets looked over because we think, well, it just provides support and that's it. But in addition to support, what are some other functions? Can anyone give me one other function of your skeletal system? Maybe something that people don't often think about. Anyone remembers from the biology days? All right, well then let's tackle this slide style and just give you a brief overview. You'll be doing some reading tonight that relates to this as well. Again, need verbal confirmation. Everyone's seeing a slide with the skeleton in front of them right now?
Yes.
Can't see the tabs.
Yeah.
All right. So this is kind of the slides that I used to use back in my biology days with some more added detail now. But there are a number of functions. Support is just one of them. Protection is the obvious thing, right? Your rib cage and your skull in particular are protecting probably your most, well, every organ is important, but some of those are very important ones. Movement, obviously, with the hinges and the fact that muscles connect to bone, we would be completely incapable of coordinated movement if we didn't have both bone and muscle working together. Mineral storage, anyone know which mineral in particular? Like why are our teeth white and our bones appear kind of bluish white?
Calcium.
Yep, very important. For the nervous system, which a lot of people don't realize, your nervous system is very dependent on calcium, especially for neurotransmitter delivery. And so the skeletal system is important for that. And I'd say this is the big one, is blood formation. I think this is something that a lot of people don't realize, or it's kind of one of these fun facts that you learn, that is where your blood comes from your bones. Usually actually from the ends of your bones, right? So the top and lower parts of your femur in particular have a lot of red bone marrow, and they're forming red blood cells, white blood cells, and all that stuff. So bones fall into 4 general categories. You have your long bones, which are the ones that everyone knows about: femur, tibia, fibula. These are the ones we're always breaking. You have flat bones. Then these are more kind of like the sternum and towards the back, your sacrum, that's what that's called. You've got short bones in your hands and your feet, which make up a majority of the bones in our skeleton if you're looking at numbers. And then the irregular bones, which are your vertebrae, which come in all kinds of weird shapes and sizes depending on what they're connected to. It's the internal anatomy that I think is really fascinating. Bones aren't just dead, right? They're living things. They have tissue inside of them. There's spongy bone, but we'll get into more detail on that in a second. But the point is that they have a hard outer core called compact bone, and then the spongy bone on the inside. I'll get to the technical terms of this soon. Bone marrow comes in 2 types. There's yellow bone marrow, which is actually just stored fat. Very important for your blood actually to flow by this and get extra energy when it's needed. And then the red bone marrow is the stem cells that create your red blood cells. This is why a lot of times when people have some type of blood cancer, they will usually immediately look at the bones because it's usually something wrong with the bone marrow, and that's why you can receive a bone marrow transplant to try to treat that. It can sometimes treat blood cancers because that's where the blood's coming from. So the compact bone I was referring to earlier is called cortical bone, and it's one of 2 types, right? The other one is called it's trabecular bone, and you can see the difference in structure here. This one's much more kind of spongy and has more space for things to kind of flow through and around. Cortical bone is always on the outside. This is the tough part, right? It's very compact. That's what won't break very easily. You also have what's called the periosteum, which is important for repair, protection, nutrition. This is what the blood vessels are attached to that then flow into the bone to keep the bone alive and provide it with nutrients and oxygen. So again, here's just a table you'll see in your reading that's comparing the 2. But the point is that this is kind of you got to think of this as the hard outer part of your bones. And then the trabecular is the inner part that's a little bit softer. And you'll also notice that like a lot of our limbs and like your working bones are mostly cortical bone, whereas like your spine and some of the more centralized ones are more trabecular. Now, bones have padding in between them that's called cartilage. If any of you crack your fingers, you can crack your fingers right now. Technically what you're doing is you're moving the cartilage, and there's some air in there sometimes too that's moving around. But that's the padding that prevents bones from rubbing together. You have cartilage in the tip of your nose, in your ear. If you feel those things, it's a tough substance, but it's not as hard as bone is. We're born with a lot of cartilage. It helps the baby's head get through the birth canal, and also just that's why young children are often so flexible, is because they have a lot of cartilage still. And then there's the joints, which are the connection points. You have immovable joints, which is what your skull is made out of, right? Our skull is several plates that are all just kind of cemented together. There's not very much movement there. They're slightly movable, so things like your elbow, which can really just go forward and back. And then your freely movable joints, which I think are the awesome ones, are like your shoulder and your hip, where your leg connects to, where you get almost 360-degree rotation. Okay, and I'm gonna stop there because I'm gonna have you do some exploration of your own and a little activity. But any questions or comments on bone stuff so far? What do you guys know? Does anyone know what we call the bones in our fingers, in our hands? Anyone know what these are called? Anyone ever heard of carpal and then metacarpal? What about the arm? Anyone know what this big bone here is called? Going through your upper arm? Most people know this. When you smack your elbow, we call it the funny bone because it's referred to as the, and I don't actually know if it's a connection or not, but it's referred to as the humerus. So, Cameron, is that what you're gonna share?
Yeah, I was gonna say
Yep.
humor.
So I'm gonna have you actually do a little flip grid where you're gonna have to look up some of the more unusual bones and point them out on your own body. So we're on the tasks to complete list. This is step number 5, flip grid activity. Go ahead and click on that assignment right there, which is Know Your Skeleton Flip Grid. It'll take you to a Canvas assignment that has instructions on what to do and a list of bones that I would like you to point out on your own body. So you're gonna film yourself, and I want you to point to your mandible, your acromion, your calcaneus, your distal phalanx 5 in your left foot, and your incus. And just take a quick guess at what you think the function of each of those bones is. It should be pretty straightforward. You don't need to do any research or anything like that, but just kind of share that in the video. Post the video to the Flipgrid. If Flipgrid isn't working for you, you can always just email me the video. But I'll give us, let's say 20 minutes to work on this. And I'll keep an eye on Flipgrid. If we're getting most of the videos in, then we'll come back together. I'll be here listening if you have any questions or if you're not sure what to do. Go for it.